This video is going to cover the topic of equation solving with grouping symbols. Be sure the date and topic are at the top of your page. Your essential question for the video is, how do we solve algebraic equations when they include grouping symbols? Grouping symbols are anything that tell us to do a whole bunch of the work in order of operations inside before moving on to the next operation. So things like parentheses, the P in PEMDAS, brackets or braces, or fraction bars, where we have something on top and something below, and we have to do everything on top before we move on. One thing to keep in mind as we solve these equations is that solving an equation is a lot like unwrapping a present. We can think of the variable as the gift inside, and we have to take everything off in the opposite order in which it was done. So if there's a bow, and there's wrapping paper, and there's a box that we have to think about, we have to figure out how we're going to open it. And if we wanted to unwrap this gift, right, we would remove the bow, we would take off the paper, we would take it out of the box, right? We would go in the opposite order in which it was put together. Mathematically, of course, we are doing the inverse operations, but sometimes it's good to have an analogy. Let's take a look at this equation that includes a parentheses or a grouping agent. The x is inside the parentheses and we have to get it out, right? We're going to try to unwrap this. When I think about the operations that were applied to x originally, right, I'm going to look inside the parentheses and I see that the first thing that happened was that we added 1. That was inside the parentheses, so if we take care of that, the next thing that happened was that it was all multiplied by 4. But of course, we want to now do everything in the reverse order and with the reverse operation. So that means we actually need to start by dividing by 4. And once we've taken care of that, we will subtract 1 instead of adding 1. All right, so these are the things that I'm going to need to do. And I'm going to kind of keep track, as I did in the past, up here on my equation. And I want to make sure I remember that this means that both sides have to remain equivalent. So if I do one thing to one side, I have to do it to the other. So my 16 here, I know that I wanted to divide by 4 first. So I'm going to divide by 4 and get 4. But if I've done that, I have to do divide by 4 on the other side. Well, 4 divided by 4 just makes 1, right? And if I have 1 on the outside, that's kind of like invisible math. I can just leave it off. So I ended up with x plus 1 equals 4. And I don't need the parentheses, right? I can just write x plus 1 equals 4 now because I'm done with my parentheses. The next step is to subtract 1, which leaves me with 3. But I have to keep things balanced. So I'm going to subtract 1 on the other side. And of course, those cancel each other out. I would just get x equals 3. The gift inside was 3. And of course, what's nice about this is that we can always know if our answer is right by checking it. So I'm going to substitute in, and I have 4 parentheses. My x, I think, is 3, plus 1 must equal 16. I'm going to follow my order of operations. The first thing I would do would be to add, which would leave me with 4 times 4, which is indeed 16. So I know, without even having to ask anybody else, that my answer works, right? I've checked it and I know I am correct. X is indeed 3. Our next example has a few extra steps, right? There's a lot going on here. We have 4x plus 6 divided by 2. And I can see that there's a fraction bar, and that's actually a grouping agent that's telling me that all of this is happening before it's divided by 2, right? That's another example of invisible math. They could have drawn these parentheses in there, but it's implied instead. So let's think about how it was wrapped, and we can then unwrap it. When I look at my original equation, I can see that the x here, before anything else, is getting multiplied by 4. After that, it appears to be adding 6 to that, right? Because that's still above our fraction bar, so we're going to add a 6. And it's only after that is done that underneath the fraction bar, we know we divide by 2. All right, so I know how the present was put together, so I can go ahead and undo everything. If the last step was to divide by 2, then I need to first multiply by 2. I'm going to do the inverse. I would then need to subtract 6, and finally divide by 4. I'm just writing out a list of everything that I need to do in the opposite order to unwrap this variable. All right, so I'm going to do the same thing I've done before. I'm going to start by multiplying by 2. The notation here is going to be a little bit strange, but I want to show that I'm multiplying this by 2, and I don't want to use a little x symbol. So I'm going to say that I'm multiplying 13 times 2, because that's my first step. And then I have to multiply this whole thing by 2. But of course, I'm just going to kind of show you here. If I had this whole thing and I divided it by 2, well, that would undo the dividing by 2 that I had there, right? That's the whole idea. So then I am left with my 4x plus 6, and of course 13 times 2 is 26. So that's just a little bit weird how we draw that there. But then I can go ahead and do the rest of it. I know I want to subtract 6 from my amount, and I'm going to do that on both sides. So I end up with 20, but to keep these equivalent, I've subtracted 6 here, which has canceled out, and I have 4x. And then my last step is to divide by 4. So I'm going to divide by 4 on both sides. 20 divided by 4 is 5, and therefore I think x must be 5. But of course I will substitute it to check. So I substitute my 5 where the x is, and if I do my order of operations, I would, on top of my division bar here, multiply, and I get 20 with my 6 still up there. And then I would get my addition would be 26. And of course, when I finally get to do my last step of dividing, I know that 13 equals 13. It works out. So I know, I'm confident that my answer is correct. X is 5. The last problem we're going to look at starts in a story form. So we know that Sammy is twice the age Tommy was 5 years ago. Sammy is 24. How old is Tommy? And we could certainly guess and check this, but we're going to be much more efficient if we write this as an algebraic equation. We don't know Tommy's age, so I'm going to use his name as our variable, but we know that we're starting by comparing it to his age 5 years ago. So I need to subtract his whatever age he is now by 5. And then Sammy is twice all of that. So I'm going to go ahead and multiply all of this by 2. And we know that Sammy is 24, so there is our equation. Take a moment and write down what operations we have to do first, and then think about how you're going to reverse that to solve and figure out Tommy's age. How'd you do? Hopefully we can agree that to solve this, we're going to need to first divide by 2, and then we're going to have to add 5. Go ahead and take a moment, pause the video, and solve this for yourself, and then we'll again check back and see how you did. How'd you do? Did you find that Tommy must be 17 years old? We're going to check that, but hopefully we agree on this already. It looks like if we substitute in 17 for Tommy's age, we do in fact see that this is a true equation. Both sides are the same. So Tommy is in fact 17 years old. So remember, we are working here with algebraic equations and solving algebraic equations by undoing or unwrapping the variable. But this is specifically showing us how to do this when there are some grouping agents, right? Things like parentheses, brackets, or fraction bars. So that was our essential question. Come with any questions in your notes for class tomorrow.